Welcome everyone. Our session today is on exploratory data analysis. So let us start. Okay, so exploratory data analysis, or in short EDA, what is that? We have data, so we are going to process data, we are going to generate some predictions from the data. But for that, it is very important that we understand the data first, right? So once some data set is given to us, so we have to generate some important outcome from the data set. So before doing that, it is very important that we have some clear understanding on the data, and for that we can take the help of some visualization techniques, and we have to make some processing as well on the data, that is data pre-processing. We'll come to that, but once we get the data, we have imported it in our maybe some pandas data frame, and then the first thing we'll do is called the exploratory data analysis. So it is actually analyzing the data set, understanding the data set by summarizing their main characteristics, often plotting them visually. So once we try to understand the data set, then visualization techniques help us a lot. As you know that once we have this data in some graphical format, then it is very easy to understand something, right? Then performing initial investigations on data. So we'll do some investigation in detail about the data, about the type of data, about the exact data, about the nature of data, and then to discover patterns. Okay, so in which pattern the data is there, right? So if there is a marks column for students, so what is the pattern means? Maybe that how the marks for a student is gradually increasing or decreasing semester by semester. So that is something pattern. Okay, so I may try to understand the marks pattern for a student, so to understand that how the student is improving, or maybe the performance is going in the opposite direction. Okay, so all these things can be discovered through patterns. Then to spot anomalies. Okay, if there are any anomalies present in the data set, that also we can do analysis. To test hypothesis and to check assumptions. Okay, so if we have some hypothesis, then we can prove it, that whether it is correct or incorrect, and then if we took some assumptions, then we can confirm that whether it is correct or not, with the help of summary statistics and graphical representations. Okay, so I can have this data about data maybe in a graphical format, or can be some summarized statistical information. Okay, so when we do the processing, we have to follow some steps. So roughly I can say these are the steps for EDA, or exploratory data analysis. They are understanding the data set, knowing about the variables. Okay, so first of all, I have to understand what is there inside the data set, what are the individual columns, what are their types, what are their range of data, those things, right? Then knowing about the variables means the features, different features are there, so what they are actually doing, what range of the data they contain, and what I can do in that data, right? Then cleaning the data set. Okay, so cleaning means maybe we can have something which are not required, there can be some duplicate records, there can be some incorrect data, there can be some missing data, so we have to take care of all these things. Okay, then analyzing relationship among the variables. So it is actually very important. So when we get a data set, we have multiple features present there, so we have to understand, like, how the features are related with one another, and based on that we can decide that which are the features or the combination of features that can help us to draw some outcome or conclusion or prediction from the given data set. Okay, so these are the steps, and let us go to Jupyter Notebook, and there we will have some data set and we'll do some hands-on EDA on that particular data set. Okay, so this is my data set. Okay, so the first step is here I am importing the important libraries. Okay, so I need NumPy, Pandas, Matplotlib and Seaborn. All these libraries we have explored with examples and hands-on exercises, so you are familiar with this, as we have already covered these things in the earlier sessions. So in case you have not gone through this, so please first you go through all these library tutorials and then you come back here, because it is very important that you understand these library functionalities before you do this exercise. Okay, so the first cell I will execute. Okay, so I have imported all the libraries, and in the next block of code, it is familiar, you are now familiar with this. So here I have called the pd.read.csv. I am reading one CSV file called train.csv in this data frame called data, and the next line is data.head. So you know that this statement is going to draw the first 5 records of the record set. Okay, so let us execute first. Okay, so you can see these are the records, first 5 records, and actually these records are about this Titanic data set. Okay, it's a very familiar, very well known data set, that is Titanic data set. And you know that ship had some bad fate, and there are a lot of passengers who died in that accident, and this data set has one column named survived. Okay, so I can say that actually my purpose of this data set analysis are these, that with the help of other features given in the data set, if I can come to some conclusion that okay, these are the features that are responsible or that are drawing this conclusion to whether that passenger had survived or not. Okay, so I may say that I will come to details on that in the next tutorials anyway, but survived is something which is a dependent variable, and rest of them or some of them are the independent variables. So actually survived is dependent on some of these features given. Okay, so my task is here that I want to draw that relationship, that exactly on which features this survived feature is dependent or how. Okay, so that is the purpose of this work, but it is very important that we understand the data set first, then only we can go to the next step. Okay, so for that it's very important that we understand that what are the data, different types of data, and as I told you, the type of data, or what is the content of that each column, those things. So I have few commands here, I will just execute one by one. So this D types column, it actually gives you the data type for all the columns present in the data set. Okay, so from this you can understand that these are the possible data. So suppose passenger ID int 64, that means all the values in the passenger ID column has some integer value. So you can have some idea about the data type for all the columns present. Okay, then the next function data.shape. So let us execute. So this actually gives you the number of rows and columns. So from the data set you can understand that there are 891 rows and 12 columns. Okay, the next one is data.columns. So again it gives you the list of columns present in the data set. Okay, so these are few of the functions that give us some summary information about the columns present in the data set. Okay, then the next function here I have written data.isNull.sum. So what it is doing, this data.isNull means it will identify the record columns which are having null values, and sum means it will actually do the total total number of null columns. Okay, so let us execute this. Okay, so from this execution you can see that this passenger ID column has 0 number of null values. Same for survived, P class, name, gender. But this age column has 177 records are having null values. Okay, so if you remember, there are total 891 records, and among them 177 of the records are having null value in age column. Okay, so we have to take care of that in the next steps. Fine. Then all the rest of the columns, these 4 rest of the columns, they are having this count as 0, so no null value. And then again this cabin column, it is having 687 null records. Okay, apart from this total 891 records, and 687 are null. Then embarked column has 2 null values. So this is a very useful function for you to understand that how many null values are present in your record set, because when you are going to some conclusion, then it is very important that data is present. If data is not present for some feature, then you have to make some assumptions, and that may be wrong in deciding the final outcome. Okay, so I understood that in this data set these 2 columns are having lot of null values, and embarked column has 2 null values. Fine. Okay, so as I told you that my purpose is that this survived column is the column for which I want to generate some relationship, means whether a person is survived or not, that whether that is dependent on the other features or characteristics for that particular passenger. Okay, so here I have one count plot, so you know that for seaborne this count plot function, and here X is survived, and I am taking the data from this data frame. So let us execute. Okay, so now you can see that this survived has 2 possible values, 0 and 1, and for 0 the count is more than 500, and for 1 the count is like nearly near about 300. So from this graph you can come to conclusion that there are people, the total record set are having more records with people who did not survive, so the chance of survival was less, right? Okay, next action. So here now I am going to access the each of the columns that are present in the data set. Okay, so the first column I am going to take care is gender. So let us first check what is the data present in gender column. Okay, so I'll first comment out this part. Okay, so if you execute this, so you can see this is the record set. So the values I can see here are male and female. Okay, that's why it's a categorical feature. So I have discussed about different data types, so it's actually categorical data. So it has 2 types of data, male and female, that I can see from the data, and I have some functionality as well that I can use, the data.group by. So I can do the group by on these 2 columns, gender and survived. It is similar to the group by of database functionalities that there you have used group by, so it is also similar. So here I am grouping the records based on gender and survived. Okay, based on both these columns, and then for the survived column I have retrieved the count. Okay, let us first execute this. So you can see how the function has worked. So it has grouped the records based on gender and survived. So you know that the possible values of survived are 0 and 1, and the possible values of gender are male and female. So actually there are 4 groups. Okay, the first one is female and 0, and there are some 81 records present. Then female and 1, it is 233 records. Similarly for male, not survived 468, and male survived is 109. So from the data also you have some understanding that among the male most of them did not survive. right? And for female the situation is just the opposite. Here the number of survivors is more than the number of people who did not survive, right? And I can plot also the similar thing. I can plot with this C-bond functionality. So here I have drawn some count plot. Let us first execute this. So you can see here that I have plotted this survived column versus the count, but here the hue is gender, so this count plot is done for survived and male, survived and female, not survived male, not survived female, 4 categories, okay, and I can get the count. So actually what you got here in data from here, you are getting this in visualization. So from this you can come to few conclusions, that first of all, this gender is a categorical feature. It is having the values male and female, and for male passengers most of them did not survive, and for female passengers more female passengers survived than the female passengers who did not survive, right? So all this information I got from this visualization techniques. Okay, so I have some understanding now about this gender column. So let us move to the next column, that is the P class column. Okay, so let us first see what is the data there in P class column. So you can see the data, it is some 1, 2, 3, these are actually the possible values for this P class column. So it's actually one ordinal feature, means it has 3 possible values, and actually it is the class of the passenger. So it is actually first class, second class and third class. So it is as it is in order, as the number represents the order in which the passengers are there. So that's why it's a ordinal feature. And let us have some functionality now implemented. Okay, so now I am grouping based on P class, and I will find the count. So I just want that what is the count in each of the classes. So you can see that I have in first class there are 216 passengers, in second class 184, and third class 491. So from this information I may come to the conclusion that most of the passengers were there in third class, then first class, and then comes the second class. Okay, so I can plot the same data also. So you can see when we have plotted using C-bond, so it is actually showing us that in the third class maximum number of passengers, then first class, and then second class, right? So almost half of the passengers are there in the third class, and the rest of the passengers are divided in first and second class. Okay, the next functionality here, I am grouping the data based on P class and survived, and again I'm printing the count of the total number of records in each group. So you can see, so as there are 3 classes, and each class there are whether survived or not survived, so actually there are 6 groups total, right? So 3 into 2, 6. So you can get the count of passengers. So let us, for better understanding, let us have the plotting of that data. So now my X value is survived and hue is P class. Okay, so let us execute. So you can see this graphical representation. So I can understand that there are less number of people who survived from this third class, but most of the third class passengers did not survive, right? And for second class passengers, I can see it is almost like 50-50. Half of them survived, half of them did not survive. And for first class passengers, the number of passengers who survived is more than the number of passengers who did not survive, right? Okay, so then there is another plotting. Here I am actually plotting with the relationship of survived with P class and gender both. Okay, that's why it's a cat plot. Here the kind is count. Okay, so when I am trying to do the count plot for multiple columns, then I can take the help of this cat plot. Okay, so you can see now that I have mentioned the column equal to gender. That's why there are two subplots are generated. One is for gender equal to male and another is for gender equal to female. Okay, so for gender male, survived and not survived, and in survived and not survived I have these different P class members, right? So if we first go to for gender male, then from the graphical representation I understand that most of the male passengers of third class did not survive. Only less number of them survived, and for second class passengers also most of them did not survive and very few of them survived. For first class passengers also the number of survival and number of not survival, they have less difference, but still more people did not survive for male passengers. Okay, now if we come to female passengers, then I can see that the number of survival for third class passengers are almost the same, means 50% of the female passengers in third class survived and 50% of them did not survive. And for first class passengers you can see that most of them survived. Okay, here it is a very small bar, so most of them actually survived, and same for second class passengers also, female passengers, so most of them survived and very few of them could not survive. So gradually I'm going to the relationship with the survival chance and the other features. So I can understand that people from third class or the male passengers, they mostly did not survive, and people from first class and female passengers mostly they survived. So I can come to many conclusions actually from this exploratory data analysis. Okay, so now I have some understanding about this P class and gender column, so I will go to the next feature, that is called the age. Okay, so let me add one new cell here. Okay, so let us first execute this. So as you already know that there are many records, some around 167 records where the age value was null. Okay, for rest of the places I can see that the values are present, that is the age in years actually. So that is the data, and it is a continuous feature. As you know that is a age is something, it's a value, and it may range from 0 to 100 I can say. So it's a continuous feature, but there are a lot of null values, right? So for this continuous feature I can calculate the minimum, maximum and average. That will help me to understand. Okay, so let us execute. So you can see that minimum age is 0.42, so actually a few months old baby, and the maximum age is 80 and the average age is around 29 years. So I have that understanding that it's a very small baby to 80 years old person, and the average is around 30 I can say. Okay, so now I'm plotting some histogram on the data, age data. So as you know that if it is a continuous data and if it is something numerical, then histogram helps us. So let us plot this. So you can see from here that most of the passengers fall between this range, right, from 20 to 40 you can say. So most of the passengers having the age group in this region, so histogram helps us to understand that. Okay, so the next thing is I'm generating some box plot where I have generated this x equal to P class, y equal to age, and hue equal to survived. Okay, now I'm trying to get some relationship between the survival and the age and the class of that passenger. Okay, so let us execute. So you know that box plot works in that way that it is something, the mean and the interquartile range are in the box format, and then you have that whisker which is giving you the range of values, and there are some values which are behind the range. Those are actually the outliers. Okay, so here if you see that the P class is plotted in the x-axis, age is in the y-axis, and survival is something like that. So from this box plot I can have some understanding that for these, for these first class passengers, these are the age group where most of the people survived, and these are the, for the people, sorry, these are the people who did not survive, and this is the people who survived. Okay, so this is some idea which is you can get that for the first class passengers there are people who did not survive, and this second class and third class passengers, they did not survive. This is the age range, right? So you can have some understanding that in which age range most of the people survived or not survived. Okay, so that I got some idea. Then I'm coming to some, again I am doing some box plot. Here I am doing some subplot. Okay, so first one is I am doing on P class and age, and second one I am doing on gender and age. So let us see how it works. Okay, so it is like the first one, so it was only P class and age, but now I'm plotting, one is gender versus age and one is P class versus age, and for survived. So you can have some understanding that what are the range of age groups, and in the P class or based on gender, in which range most of the people actually survived. Okay, so this box plots will give you a lot of ideas. Okay, so next one is another kind of plot that is called violin plot. It is also belong to seaborne. It is like box plot. It has similarity with box plot, but it actually shows you, means box plot means it's a something rough idea, some box format it is showing, but in violin you actually get the exact nature of distribution of the data. So let us first plot it so you can understand. So you can see, so actually this is how the data is there. Okay, so you can see, suppose for survived, people survived for first class, so you can see that in this age range most of the people survived here, right? And then it is actually reduced in both the sides, and these are the maximum, minimum and maximum age range where people survived. So it is actually like box plot, but it gives you the distribution of data, exact distribution of data also you can understand from violin plot. Okay, so the another violin plot I have drawn with gender and age. So it was P class and age, and this is gender and age. So this is the violin plot. Okay, then this is, I can do some splitting also in the same plot. I'll show you this one. So let us first execute this. Okay, so here you can see that this survival and not survival, instead of doing two violin plots, it is the single one where it is shown. Okay, so for suppose for first class, this is the age range where people did not survive, and this is the age range where people survived. So it is in the single violin you are seeing that two different types of data. So this is for this split equal to true. Okay, so if split equal to false, then there will be two violin plot for each of these q variable. Okay, and as here split equal to true, so for survived, the 0 and 1 values, one single violin is drawn. So that's the difference. So from these plots you can have some understanding that in for which gender and which age category people actually survived or not survived. Okay, fine. Now now the problem is there with the age column. I told you that as there are many people who had not having the data in the H column, right? So we have to handle the missing data. There are many options. The first one is if there are a lot of null data in a column, then we can remove that column from the data set and we can proceed further. But the problem is that as the column is removed, then that column is not going to help us in generating predictions or some outcomes, but it may be possible that that column was very important, at least for the columns where data was present. So sometimes it may not be correct to just remove the column. Then another option is for missing data is that we can have some default value, very commonly the mean of the values. Okay, so here in our case, for the H column, the mean value was, if you remember, it was 29 years, right? But the data range was something from 0.42 to 80 years. So maybe for some person having age 70, so if we put that mean 29, then that will be wrong, right? Means that is quite a wrong value, and it is not really in a acceptable range. So putting the mean value actually will not work here, because it's a huge range of age, right, from minimum to maximum. So we can go in some other direction. So in this data set there is a column called name of the passenger. Okay, and for most of the time these passenger names have this salutation, means Mr. X, Miss Y, like that. So I can take help of that. So here what I am doing, here I have added a new column in the data frame, that is salutation, and for all the data, for all the records in this data frame, what I am doing, that I'm taking that substring of where it is having this any combination of A to Z values, and then this dot, because generally it is Mr. dot, then the name and surname, right, this format. So for that way, from the name column I have tried to retrieve that part. Okay, let us see how it works. So if we execute this, so you can see for these records from the name column I have retrieved these parts. Okay, so let us see. So now if I do this group by on this salutation column, so let us see how many different types of salutations I could retrieve from the name column. So you can see that, okay, so there are actually many types of salutations. Most of them are this, like master is 40, miss 182, Mr. is 517, Mrs. is 125. But there are other salutations as well, maybe by mistake, or there was no checking that what can be the valid values for salutation. But what I can do, that I can stick to these 4, that I will take these 4s and rest of them I will just convert them. Okay, so you can do it with different approaches, some common sense and some common practices you can follow. Here what I have done for all these types of salutations, you can see I have converted them to Mr. Okay, in place equal to true means that it will actually change the original data set where I am making the changes. Okay, so let us execute this. Fine, so it is executed. Next, if I again execute this part, so now you can see that it is reduced and there are still some of the salutations present. So in the next step, what I am doing, for these 3 salutations, I am converting them to misses. Okay, again I am telling that this approach may vary based on the data set, your prior knowledge, or some experience, or some assumptions. Okay, and we have to always clearly mention the assumptions in the final result, that we have taken this type of assumptions in our data set. Okay, fine, still some of them are present, so I will again change this. So I will change this 3 to miss. So now if we execute this, now I can see that for all the records this salutation are having these 4 possible values. Okay, so now I am doing this based on salutation. I am calculating the mean of age. Okay, so actually what I am doing for these 40 records, I am taking the mean of the age. Okay, for these 186 records I am taking the mean of the age for this and this. So the purpose is here that if the name is master, so I can understand that it's a boy, okay, a kid maybe, and miss means some young ladies, okay, and Mr. means the boys, but they are adults maybe, and Mrs. means they are some older ladies. So I'm actually trying to calculate the mean, but based on the salutation, so I'm actually reducing the range of values for them. So 4 categories I'm actually doing. So if you execute this, so you can see that this is the average value for this category. So now what I am doing in this next block of statements, so you can see data.log. So log function we have already used. So inside that I am actually retrieving the columns where the age column is having this null value and this salutation is master. So for this age column I am setting it as 5. Okay, so for all the records having the age column null and the salutation is master, there I am setting the age as 5. Similarly for Miss and Mr. and Mrs. with these different mean values. Okay, I'm just populating the null values of these particular salutations to these 4 different values. Okay, then let us have this. Okay, again I am doing some box plot for this P class age and gender and age that we have done before, but that time there are a lot of null values. Now there is no null value, so it is getting plotted, but it will be of course little bit different from the earlier one. Okay, next I am again doing some plots. I am going to do this time it is the histograms. Okay, so let us see how it works. Okay, so you can see that 2 histograms I have drawn. One is for the not survived and one is for the survived. Okay, so this not survived, this is the frequency range based on the age. Okay, so what is the age group and how people did not survive. So you can understand that for this age group 30 to 40 most of the people did not survive, and here also the same thing. Okay, because you know why this happened, because actually now most of the records are having this age group only because of the mean value we have put. So this histograms actually show you the relationship between age group and the how they survived. Okay, so now I come to another column, that is embarked column. Okay, so let us put this the different cell. Okay. So if you see the data, it is actually having some values A, C, Q. So actually it's a categorical value, categorical feature. Okay, so if you see the data, so you can see that there are 3 categories having these values. Okay, most of them have embarked from S and then C and then Q. Okay, so now let us see this data. So now I will calculate that what are the null values for this column. So there are 2 records. So as there are only 2 records, so what I am doing, that as most of the records are having this value as S, so I'll just replace these records having null values with this S value. Okay, so this is a functionality fill. Now what it will do, it will just replace these null values with this value. So let us execute this. Fine. Now if you execute this, you will see that 0. Okay, so no null value is present now. Now let us plot this survived and this based on this embarked. Okay, count plot I will generate. So now you can see based on these 3 embarked values S, C and Q. So you can see that from the plot I understand that most of the passengers embarked from this S, and most of them actually could not survive. And for the C point of embarkment, here you can see that the survival is more than for the people who did not survive. Okay, and for this Q value, actually people who survived are less than the people who did not survive. So actually I can see that people who embarked from C are the people who are mostly survived, okay, compared to not survived. Now again I will draw some plot where based on column equal to P class. So actually I will have different subplots for different P class. So you can see here that based on this P class, so if I consider this first class passengers, you can see that this green part is negligible. So actually most of them embarked from the points S and C, and people who embarked from C survived mostly, and for this S also. So more people survived, as it is first class, you understand, obviously. And for second class people also, this Q point of embarkment is very less, and here people, most of them means almost 50-50, but few percentage more for people who did not survive. Okay, and for this C point of embarkment, it is almost 50% of them survived and 50% didn't. And then we come to P class equal to 3. Here you can see this green block. So people who embarked from this Q point, they are mostly in the third class, and more of them did not survive, and less number of people survived. And for the embarkment point S, most of them did not survive, and a few people survived. Okay. So let us go to the next feature then. Okay. So now the next column is C base P. So let us have the data. Okay. So if you just print the data, you can see some 1, 0 values, and okay, most of the values are 1 and 0. So I will group by this. Let us see how many possible types of values. So you can see 0, 1, 2, 3, 4, 5, 8. Actually this number signifies that how many siblings are present with that passenger, means whether that passenger is alone or he or she has some brothers or sisters, like that, siblings. Okay, so you can see that most of the passengers are having this count as 0, so they were alone. And then 209 people having 1 sibling, 28 people having 2, 16 people having 3, and there are very few number of people having more than 3 siblings. Okay, so let us plot this, that how this number of siblings affected the survival chance. Okay, so I will plot it. So you can see that actually most of the people are having no sibling or 1 sibling, as you saw, and this is the rate how they survived or not survived. Okay, then I am again plotting based on not only number of siblings but the class also, and in different subplots for survived and not survived. Okay, so if you execute, you can see for survived 0, oh, so this green means this 3, so it's actually for third class people having, most of them are don't having any siblings and they did not survive. You can see this large pillar, that is the how the distribution of data. You can check this graph and have some understanding. Okay, now I'm going to the next plot. Okay, so here I am plotting this class and siblings, how they are distributed, how the number of siblings based on class. So you can see that most of the people in the third class are having no sibling and then one sibling, and others are actually this number of more siblings are mainly for the third class passengers, and for first class and second class passengers most of them are having 0 or 1 siblings, and very few are having 2 or 3 siblings. Okay, so I have the understanding about the data and their relationships between different features. Okay, so you have some idea. Next column is purge column. So let us see the data. So if you do the group by simply, so you can see that it is also having these possible values 0, 1, 2, 3, 4, 5, 6. Actually this is the number of parents the person having, the passenger having. Okay, so you can see that most of them are single, and there are some of them are having 1 or 2 parents, and there are very few who are having more than 2 parents. Okay, so let us plot it again similar to this number of siblings. So if you plot, you can see that as most of the passengers are zero number of parents, and from them it is most of them did not survive and some of them survived, and then that is how they are distributed. Okay, then let us have some relationship between class and number of parents, and then how they survived. So different subplots for different survival. So the people who survived, if you can see the number of parents, so it is like for 0, 1, 2, most of them are having parents 0 or 1 or 2 that survived, and here you can see that these third class passengers having no parent, most of them did not survive, right? So this is how it is distributed. Then I am plotting this again, this class and relationship between the class of passenger and number of parents. So if you execute, you can see that this more number of parents are actually very less, and they are also from the third class passengers. Okay, and for first or second class they are mostly having 0, 1 or 2 parents. So that is the relationship. Okay, then there is another column called fare. Okay, so it's actually a continuous feature. So I will add a new cell here. So execute. So this is the data. It is actually the fare for that passenger, so it's a continuous feature, you can understand. And I can calculate the minimum, maximum and the mean value for the fare. So mean value is 0, that means there were some passengers they did not pay anything, and the maximum fare is this $512, and average fare is $32. Okay, then I am drawing the heat map. So now I just want to have the understanding of correlationship among all the features. This data.correlation function I have called. Okay, so let us execute this. So you can see the correlation among all the features. So we have already explained it in the Seaborn tutorial. So here you can see that the correlation is, for most of the columns it is very less. here I can see this minus 0.58. So this is the relationship between this P class and fair. So of course there is a relationship, right? Because as the class is increasing or decreasing actually, so 1 2 3, so the fair also, if the class number is less, the fair is more. So that's why it's a high relationship is there, but in the negative direction. So this is one having good value. There is another one is this, so I can see 0.41. so it is actually the relationship between number of parents and number of siblings. So actually the people having siblings are having the parents as well. So that is one relationship. Two relationships I can get from this heat map. Okay. And for other columns I am not getting much significant relationship, very less value, most of the sets. Okay. Then another important thing is, so far we have discussed about the relationship among different features, and we now have a lot of idea about the data type and the exact data in the column, and we have handled the missing data as well for the columns. Okay, so I found that this passenger ID, this kind of ID field, so it cannot have any relationship with the survival column, and their name, it also does not to do anything to do with the survival, right? There should not be any relationship between name and how the passenger was survived or not. So that is some common understanding, and not always this common understanding works, but we have to do the analysis of the data. We may have to talk to people who have understanding about the data and actual scenario. So based on those information, here I will remove the irrelevant columns. Okay, that will not help us doing the prediction or the outcome analysis. So here in this case I have removed all these 4 columns, they are not required. Okay, so I just drop these columns from my data set. So now if you execute, you can see that I have this many columns, only these columns I have removed. Okay. Then sometimes I'll rename my columns, maybe because sometimes they are confusing, the names may be confusing, and that may be difficult to understand. So whenever we are reading the data or we are processing, then a good name of the column actually help us to understand and to process it in a better way. So here I thought that these 2 columns are little bit confusing names, rest of them are quite clear to us. So here I have renamed the columns, this parts to number of parents and C base P to number of siblings. So when I see this name of the column, then I instantly understand that it is for the passenger, what is the number of parents. So this way I have done these 2 renaming of the columns. So let us do this. Have executed. Next I will again run this. So now you can see that column names are changed. So I have done some exploratory data analysis on this Titanic data set. So my outcome is that I have removed all the unnecessary columns. I have renamed the columns for better readability and processing. Then I have handled the missing values. Okay, and then I could understand what is the type of data in different columns and what is the nature of data and how they are related with each other and how they are related with the survival chance of the passenger. So all this information I got through this exploratory data analysis. So now I have some basic idea and we'll move to the next step. So for now this session is done. Thank you.